I'm going to go through 2303. I've been asked to do question 3 and question 4. So let's have a go at doing that first. So we'll start with question 3. It says a particle moves in a straight line from an origin, so its acceleration at time t seconds is given by blah. So if the particle is momentarily at rest when t equals 2, find an expression for its velocity. So first of all, we've given us a given acceleration, so I'll start there. Let's have a look. So one second, just grabbing stuff I'm throwing on the floor. So we've got an acceleration formula. So I'll write here, so 23.03. And we've got acceleration. Oops, I'm trying to get all this on the camera at the same time, sorry. Okay, here, that's better. All right. So acceleration, this is question 3. This is question 3a, and we've got acceleration is 4 minus 3t. Now we're asked, or we're told rather, the velocity when t equals 2 is what we need to find. We need to find an expression for velocity at t equals 2. So I'll put here velocity is going to equal the integral of a with respect to time. Or we could rewrite that, if you like, as integral of 4 minus 3t with respect to time. You can write it either way. So we're going to integrate that now. So we're going to add one dimension of t. So we've got 4, now we're going to add an extra t. At the moment it's 4. So if I wrote that as it is, it's actually 4t to the 0 minus 3t to the 1. That's what it is. But let's now change that, and I'm going to add an extra t to each one. So that 0 is going to become a 1 and divide it by 1. The t here is going to become a 2, and we're going to divide it by 2. So we're going to end up here with 4t, and this is going to be minus 3 over 2 t squared. Now we need to compensate for the fact there may be another element there, so I'm just going to add plus c to the end. Now we're told though that, well, where is it here? Here we go. We're told, it's a matter of getting everything on the screen at the same time, at t equals 2 and the particle's at rest. At rest means it's going to, so here at this point, wherever this point is, v equals 0 and t equals 2. So I can actually just write that now. So at t equals 2, v equals 0. So I'm going to rewrite that. So 0 is going to equal 4t minus 3 on 2 t squared plus c. Now I'm going to add in the 2. What was it? I can add in the, oh sorry, it's time 2, not t equals 0. What am I doing? So I'll get rid of that 0. Here it is. Make that a 2. Here we go. So now we've got 0 is equal to, now we're going to be able to find the c value, because we've got 4 times 2, there's our 2, minus 3 over 2 times 2 squared plus whatever c, whatever our constant happens to be. So it's going to be 8 minus, now I've got 2 2's are 4, times 3 is 12, divided by 2 is 6, is 8, so plus c. So this is going to be equal to 2 plus c is 0, so c is equal to negative 2. So that's the value of c. Now what we need to do is to formulate the equation. So up until now we've got most of it. Here it is. We've got that bit there. We just need now to add in the c value and give it a name. So here we go. We've got our c value, and we're going to say velocity. So therefore v is equal to 4t minus 3 over 2 t squared, and we can put minus 2 on the end. And that would be the equation for velocity. You might decide to put it in order of powers, in descending order. So you might go negative 3 over 2 t squared plus 4t minus 2. That probably would be my preference, but in order to keep it more succinct, you can tuck the negatives inside, and that's probably a good idea too. So that's how I would express the answer.